Hello, welcome. I am Mr. Rogers, and you are watching the video notes for this will be on Chapter 2, Section 1, which is on electric charge and static electricity. So this will be one of those units in this lesson where after you talk about it and we start doing some labs in class, this will be like, oh, I've seen that before. Oh, I've done that before. It's a lot of that everyday phenomenon we're talking a lot about in this first unit. So in the first lesson, electric charge and static electricity, we're talking about putting kind of magnetism behind us right now, and we're focusing on electricity. So no more magnetic materials. Now we're really dealing with those positive and negative charges like we see with electricity. And our first unit's all about static electricity. Static electricity, as you can see here from the notes, is a buildup of charge on objects. So static is kind of the key word. Static means it's not really moving; it's staying on that object. We think about a current flowing through a wire, that those electrons are moving. And static electricity, that's staying in the same place. So there's some basic rules we're going to look at, and it's very similar to magnetism we just finished there. Our basic rules are charges that are the same repel each other, and charges that are different attract each other. So two positive charges would repel each other, two negative charges would repel, but a positive and a negative would attract each other. And what these charges are creating is they're creating an electric field. And an electric field is a charge or charged area that exerts a force. And a force, remember, is a push or a pull. So it's as a force. It can push and pull on objects. Now, and this is the idea of static electricity, the buildup of charges on an object. So in static electricity, charges build up but do not flow. They're in one place. They're building up on the object, not flowing from place to place. Now, I want to take a jump ahead here. And what we mean by this, if you have a positive charge here, here's a positive electrical charge, and here's that electric field around it. And over here, here's a negative charge, and the negative field around it. And you can see, if you put them side by side, you kind of see these arrows kind of going the same direction, so these opposites would attract. But if we have two positives here, you can see now the fields, the arrows are kind of pointing at each other. This would be an indication that they are repelling. They're pushing toward each other and repelling each other away. Over here, attracting, but like charges will repel each other. And so we see the same thing with our negative charges. Now these two arrows tend to be repelling each other. These fields are repelling each other, not attracting. But on this side, the arrows tend to flow that same direction. That's a sign that the two charges are attracting each other. So when we talk about these electric charges, we're talking about a negative charge or a positive, again, electrical charge. This goes back to the electron. But we're dealing with materials that aren't necessarily magnetic anymore. We're moving away from that. These are static electric charges. All right, we're going to jump back. So how do we create these electric charges? How do we build up charges on an object? And there's three main ways we can build up charges, or they can be transferred in objects. The first one is friction. Friction is a transfer of electrons from one object to another by rubbing. The classic example is if you had a balloon and you rub it on your hair and your hair starts to stand up. You have built up those electrons, those charges on your hair, and obviously now they're attracting to the balloon because they're opposites. The idea of conduction. Conduction is the transfer of electrons from one charged object to another by direct contact. If you've ever been shocked by a door handle in the wintertime when it's cold outside and dry, that'd be conduction. And the third type, down here at the bottom, is induction. Induction is the movement of electrons to one part of an object caused by the electric field of another. So in this case, we just get the object close to another and it starts to push and move around the electric charges in the object. So the field itself is really creating the charge and pushing the charges usually away or toward the object. So these are three main ways we kind of build up or transfer charges through friction, conduction, and induction. Now, when we talk about static charges, or electric charges in general, we have something called the conservation of charge. And this goes into the conservation of mass in future units. Typically we think of conservation, we think of trying to save something. We're conserving water, or conserving land. The conservation of charge, anytime you see the conservation of charge, conservation of mass, conservation of energy, all are really the same idea. It's saying that charges are neither created or destroyed, they are transferred from one location to another. So those charges have to come from somewhere. They're building up electrons from different objects. They can't just come out of thin air. Because those charges were somewhere to begin with, and they've just been moved around by different means. It's really that idea that we can't create or destroy matter. It's already here. And that's the idea of conservation of charge. Now, what happens here, when a negatively charged object and a positively charged object are brought together, the electrons move until both objects have the same charge. Because that buildup over time, it gets to be too much and wants to balance out. The charges like to be balanced. And so what happens is we get this static discharge. And a static discharge is the loss of static electricity as electric charges move off an object. And so we see this in the form, like I said before, if you've ever been shocked by the doorknob or getting out of your car, sometimes it happens too. Also, lightning is just a massive example of that static discharge or static electricity. It's that charges between the cloud and the ground balancing each other out. And down here lastly, we do have one device we kind of use to measure how static charge is building up on an object, and it's called an electroscope. An electroscope is a device that can detect electric charges. So this is a quick overview of static electricity, and we'll do more in the future. Thank you guys.